Okay, let's see. Now we start it.
Sorry. So I had a question. So is it every Friday that you do Zoom with Tech too? Or
Only take two.
okay, so we will never be doing Friday then.
You not do nothing.
Okay, cool. All right, thank you.
Only thing is, we need on up assignment. Okay, have to be done. So basically, you work more hour at home. Okay. Okay. So now we're talking about basic for the electronic. That's what we're talking about, the DC and AC. Okay, you know the DC direct current. That means the current flowing only one direction, from the positive to the negative. And another one alternating current. That means the AC current, they go both directions, positive and negative. If you're looking at the DC here, okay, where you get the DC?
A
Where
battery?
you get DC?
In the positive?
Yeah, in the positive, but where you can see the car battery. Okay, how many volts?
12.
12 volt, correct? And you get a one red positive and the black will be negative. You understand me? Whatever they want to do, they must be using DC power, not AC. Okay? I given you example. In the computer, okay? They have to using DC voltage. Normally 5 volts, okay? Or in any equipment in your house, okay? They have to using DC power, okay? Like the heater, okay? Microwave, everything. They must be using DC. And now the AC. You can see the AC here. This is the positive, this is the negative, and this is the time domain. What that mean? That means the signal changing with the time. Okay, where you get the AC signal? Where? Where you get this signal? Where?
From a generator.
Now, easy. You can get that from your outlet, correct?
Yes.
Okay. If you're looking
Correct.
if you're looking into the oscilloscope at your outlet, you can see this signal. Okay, that is the AC. And if normally they telling you they will be 110 volt I am at. Now, this is basically we have to know. Nothing to talking about DC. This is for AC. AC signal. When you're looking this signal, you know the name will be a sine wave. That's just basically definition we have to follow. Not quite. Time domain. Amplitude vary with the time. This is the time domain. This is the 0, and this will be 1 millisecond. Okay? We pick what that means. That means from a 0 go to the top, or 0 go to the bottom here. That's what we call a peak. And this will be a 5 volt. And now, if the voltage from the top to the bottom here, that's what they say V peak to peak. That means 2 times V peak is 10 volts. Now, normally when you're working on the left, say on the oscilloscope, you will receive this signal. Okay? However, they deal with the V I am at. What that means? Effective voltage. Okay? If you buy any equipment, if you're looking in the back, you will be see they said 110 volts. That will be volt AC or volt I am at. Okay? They're not talking about that side wave. Only thing we're working on electronics, and you will do with that side wave. So, in order to get the effective voltage I am at, you take the peak time 0.707. Okay? And now they're talking about period. Period, that means you get a sine wave stuck here. They're going up, going down, and now go up again. That means they repeat it. Okay? That counts for 1 period. And this will be 1 millisecond. So the period, in this case, they will be 1 millisecond. Okay? And now we're talking about frequency. Unit will be in hertz. Okay? For the frequency, if you want to calculate the frequency, F will be equal to 1 divided to the T period. In this formula, T will be in second, F will be in hertz. Or if you get the frequency, you want to calculate the period. This is the formula. Okay? So, whenever you're looking into this signal, you're able to recognize what is the volt peak, what is the volt peak to peak. How can we get the VIMS or effective voltage? How do we get the period? And how do we get the frequency? Okay, that's what we wanted. Now, this is a basic definition. Try to read it. What is the cycle? One complete occurrence of a repeating wave, periodic signal, such as one positive and one negative alternation of a sine wave. And what is the different definition frequency? Frequency, the number of cycle of a signal that occur in 1 second. And what is the period? The time distance between two similar points on a periodic wave. Okay, that really need for you to read. Now, next one. Common power of 10 multiplier.
Professor, why was the effective voltage peak times 0.707?
That is the formula.
Okay.
Okay, we don't make it up. The thing is, normally they're talking about the IMS. They're not talking about the peak to peak. On the equipment you buy, just look into your amplifier at your home. In the back, they say VIMS, not the sideways. Sideways, you only see when you're working on the circuitry. Everything they're using outside will be VIMS, okay, or effective voltage. Okay?
Okay. Thank you.
Common power, at least you need to know. Or if it's not new to you, you can open and try see over and over. 1 million, they're using 10 power of 6, power of 3, power of 4, power of 3, power of 2, power of 1, power of 0. That means they're using the 10 to whatever power. And if you get 0.00001, and now 10 power minus 6, minus 5, minus 4, minus 3, minus 2, minus 1. Okay, and 0. This one, nothing to explain. Okay, you need to know to handle with the large number in electronic system. Use power of 10 notation. The thing is, the number is too big. So that's why they're using 10 power to make it better. The number 10 equals the base, and its power equals exponent. 247. Okay, now 247,000. You can write different way. 2.47 times 10 power of 5. That means if you take 2 and dot here, 2 point, and how many digits left? 1, 2, 3, 4, 5. That's what they're using 10 power of 5. Okay, same thing. Apply for that one. Only thing, the power will be minus. Okay, not plus. Based on this thing here. Okay, that at least technicians have to know. Okay, multiplication and division using power of 10. That's what we try to training very basic for everyone. Okay, you want to multiply 1.2 times 10 power of 3 times 1.5 times 10 power of 4. What you can do? Take 1.2 times 1.5. Okay, and the power you have to add them up. Okay, and you get 1.8 times 10 power 7. Division, you take 4.5 times 10 power of 2, divide to 3 times 10 power minus 2. So first thing you take 4.5 divide 3, that one. And the power you can use is 2 minus 2 minus 2. The answer will be 1.5 times 10 power 4. Okay? And this is just an example for you guys to do. Convert following number to power of 10. Notation. Okay? You can try. This one I already given to you the answer. Okay? Make sure you can get the answer. Otherwise, next time you can ask me. Okay? addition or subtraction using power of 10. If you're adding 3.25 times 10 power 2 and 5 times 10 power 3. Okay, so if you want to add them up, okay, or subtraction, first thing you have to make the same power. This is power 10 power 2, 10 power 3. Either way you want. If you want 10 power of 2, then you have to change that one to 10 power of 2. How can we change that to 10 power of 2?
50 times 10.2.
That
10 to the
means
second.
going down 10, right? 10 power of 3 now going down to 10 power of 2. That means you increase this number, okay, 10 times. So that's why you can get 5 times 10 power of 3 will be 50 times 10 power of 2. Then now you can add them up, okay? When you add them up, you add them that one and this one, you get 53.25. Power will be the same, okay? That is the way. How do we add or subtraction, okay? Make sure you must be changed to the same power. That's what we want. Power, raising a number to power. Here, form multiplication or division, okay? For example, 2 times 10 power 3 power, take the square, okay? That means, see what you get. 2 times 2, that is the first. You get 4. Power 10 power 3 square 2, you take 2 times 3, power 6, okay? So, this is just show you how to do. And also, in here, okay, expand the following here. And they already get the answer here. You can try to working on that. Any question, then you can ask it. Okay? And now we go to engineering prefix. That means 10 power of 12. They call it tera. And that will be capital T. Power of 9, giga. G. Mega amp. Kilo K. Milli. Lower K amp. Micro. Nano. Pico. I guarantee you cannot memorize right away. However, keep doing it and you will be getting along with that. Okay? In here, they telling you convert 0.1 millivolt to kilovolt. Okay? So first thing you get 0.1 times. Okay? Mega volt. Mega here. 10 power of 6. Okay? Kilo will be 10 power of 3. So that's why 0.1 times 10 power of 3. You get kilovolt. Okay? And express the following in engineering notation. Okay? You can see the answer. Now, try to see how the DC power working. This is your car battery. Okay? They connect to the headlight of your car. Okay? When you turn it on, the current will be flowing. from the positive. Current we call I. Goes to the line, then the line will be turned on. Okay. You know what is it here?
A filament.
Basically, just a resistor. Okay. When the current flow through that one, that will be turn it on. Okay. They get the light. Okay. And the current go to back here and go to the negative. Okay. So when you turn it off, that means current cannot flow here. So that's why this line will be turned off. So in here with the resistance, when they get the current flow through it, okay, you can see they heat it up. If you touch into the line, you can feel it really warm and hot. Okay, the thing is electrical converting into the heat. Okay. Now they're talking about resistance. Resistance is opposition to electric flowing. Okay. A component manufacturer to have a resistance is called a resistor. Conductor like copper have little resistance. Okay, so basically resistance will be a opposite to the current flowing. I given you example. If you want to fix something, the light or whatever on the ceiling, they suggest you better stand on the table. Okay? The thing is the table just like resistance. They cannot conduct any current. So if you get shocked, they go to your body. Your body will be a good conductor, the thing of water. However, they hit into the table, then do okay. Okay? Otherwise, if you sit on the floor, they can go to the ground. Okay? So resistor symbol will be look like that one. When you're working on in the company, you see this symbol, you know that resistance. The letter symbol is R. Unit of resistance is ohm. And they can using this symbol either way. Okay? This just a little detail about the resistor. Okay, we don't care that. Okay, now you can see these are different types of resistor. 1, 2, 3, 4, 5. They can be bigger, smaller, depending on how much they can handle the power. That means when you get a small resistance, you put more current into that resistance, they burn out. Okay. Another different resistance. That's just for your knowledge. When you're working, you see that type of the resistance, you know, you can recognize. Also, this is the what they call integrate. Okay, for resistor, that means inside they can get 1, 2, 3, 4, 5, 6, 7 resistor. Okay, why do we need that type of resistor? You understand the register using everywhere. When they build the computer, they need a register. So basically in here you get 7 register. So if they put a separate register, they need more room. They don't want that. So that's why they make this one. 7 register, but they can be shared the room, okay, for the computer. That's the difference. And
There was
another
8
one,
of them.
yeah,
There was 8, not 7.
okay, now I telling you. You say how many? You say 8, right? Mr. Smith? You say 1, 2, 3, 4, 5, 6, 7, 8, right?
Yes,
That's wrong. I said 7. You have to count from here, not here. You see the dot here? That need to be connected either into power, okay? Or either the other side will be to route. But they not register on the first one, only 7 one. Okay?
is it always like that?
On the way, on time.
Okay,
Okay, you can get more register, however. On up the IC register here, they have to get the one, either you want connect to power or you want connect to route. Okay? Here's another one. They call a variable. What that mean? Variable register means you can adjust that one to get any value of the register you want. Okay? For example, if they say this one 2 kilo ohm variable, that means you can adjust the resistor for from 1 ohm up to 1 kilo ohm. Okay? That's a difference.
Are those potentiometers?
Yeah.
Okay.
Same thing. Now, we're talking about color. Resistor color code. Okay, now if I given you the resistor, I can asking you what the value of the resistor. On this part here, we're talking about they teaching for assembler people. That means they're looking into the color code. They're able to telling you what is the value. Okay? Anyway, I still think for you. But to technician, if they given you resistor, they can asking you what is the value of this resistor. The answer will be, if you want the value, I need the table with the color code I can tell you. However, to me, you give it to me the meter. That's what we call a DMM. I can measure and telling you the value. That's the technician job. Okay. However, now we go into the calculation by the color. General purpose. Register 4 band. 1, 2, 3, 4. First band we call a first significant digit. Second digit. This one will be multiplier. This one will be tolerable. Okay. Precision register, they get 5 bands. Same thing. Okay. Only the difference will be the cost for the general purpose is cheaper. The cost for precision will be more expensive. I given you example. You can buy this one for 5 cents. However, if you want to buy that one, it will be 25 cents. Okay? The thing is, we're telling you more accurate. Okay?
Mr.
Now-
Sam, what was the blue band for?
Let's see. Blue is
Yeah, the
Toilet.
first four,
tolerant.
Uh,
Okay? That's
okay, the first one has four bands.
one band. Here, first band, second band. That will be third band. Okay? And
Right.
that will be, let's see, go and multiply and tolerant. Same thing here. Only the difference will be minor. Okay?
Well, you got, say, you got,
Now, when you going up to that one, okay, that will be telling you. First thing you try to understand for general.
right.
First band, this is a column. Whatever number. Second band, second digit, same thing. Third band multiplier. Four band, just a tolerant. Okay?
So for the first one, will we say 66 times 10 to the 6?
Yeah, whatever. We'll give you example here.
And we will say ohms?
Yeah, just a minute. Now we go here. That's what they given you here. Okay? If they given you a resistor manufacturer produce carbon composition 100 mega ohm with a tolerance plus minus 5%, what will be the color code on the resistor? Let's see what they say, 100 mega ohm.
Would it be gold?
Just a minute. Okay, 100 mega ohm. Okay, so basically, can you tell me by the color? So the first color will be for first digit. Okay, normally they will be what number?
I'm sorry, say that again?
Just a minute. Brown, black, violet, gold. Okay, first thing, you want 100 mega ohm. So the first one, that will be a 1 here. That will be a 1. Okay, let's see. Black, a second one. Okay, second digit will be 0. First one you get a 1, the second digit will be 0. Okay, and now you have to multiply by violet. Okay, is it violet will be 7, right? You want a mega ohm.
Is it mega 10 to the 6?
Brown, black, violet, gold. Okay, so first thing you get the brown, next one you get the black. Okay, will be multiplied by how many? Violet, right here. Right? That will be given you 1 times 1 10 times 10 power 7. Okay, that given you the value 100 mega ohm. And now gold will be here. And if you get the gold in here, okay, what you will be get? Plus or minus 5% tolerance. Now, I want to talk to you about tolerance.
Can you explain how you got violet on the multiplier?
Violet here. Get the violet here, right?
Yes.
Violet, that means for multiplier. Okay? That means you have to using 10 power 7. First digit for the first band, they want number 1. Second, black second band, you have to using second. And the next one for multiplier, violet, this is a violet. Okay? Then you can go to this number. That's how you get that number. And the last one will be gold. Gold will be a tolerance. This is a tolerance. Okay? Plus minus 5%. Okay? Let's see where we are now.
I have a quick question.
Just a minute.
Okay.
Okay.
So in the previous example, I think the other students' questions were how you went from 10 to 100, making it mega ohms. Is that because mega is 10 to the 6th, but we needed the extra 0, so you went to violet, which is 10 to the 7th, giving us that extra 0?
Okay, now they
Creating that
say
value?
that will be 100 mega ohm, right?
Yeah.
So 100 mega ohm. Mega ohm will be a power of what?
Power to
Mega's
the
the-
6.
10 to the 6th, yeah.
100 times 10 power of 6. Oh, right, same thing. Is it correct? 100 mega ohm. Same thing, 100 times 10 power of 6 ohm. Is it okay?
Yes.
Okay.
Yes.
The thing is, either way, they okay. They're working. So now, they want to get the first will be first digit. First digit, you want it to be number 1. That one here. The second digit. And you want it to be 0. That's the second digit. Okay? So now you still get the 1 0 right here. So basically 10 power of 6, they have to be same thing. Go to 10 power 7. So the third one will be multiplier. And multiply, you want it to be a 7. So that's why, okay. So that's why you can see. The first one, you get first digit, you get 1. The second digit, they given you the black. The black will be right here. That will be 0. So they want to given you the first one, the second one. And now you have to multiply to 10 whatever power to make it 100 mega. So they say violet here. You go to the multiply, you can get 10 power 7. So that's why you get 10 power 7. Okay? So that's why the answer will be brown, black, violet, and gold. Okay? And now what you need to do is they given you here and you try the best way you can get the answer. Okay? Now, I'm talking about the tolerance. I gave it to you resistor value. I get a resistor 100 ohm. Okay. No way you can get the exact value of 100 ohm. So that's why they're asking about tolerance. Plus, minus, %. So if you get 100 ohm, I want to find out what is the up limit. %, of 100 ohm. So the up limit will be what? You take 100 times 5 divide 100. What you get? Is it 5?
Yeah, it's 5.
5, that means adding to 100, you can get 90, no, 110, then 105, sorry. Is it right? That means
Right, it's 105, 105,
that plus 5,
105.
105. Oh. Okay. And then will be lower limit.
100 minus 5, 95.
95. Perfect. Will be 100 minus 5. 95 ohm. Okay. So basically you can see right here 100 ohm. Up here 105. In here 95. Okay. So the value will be acceptable from here to here.
Does that mean the device can tolerate the current at that intensity?
Yeah, if you get a value, you get 110 ohm, is it okay or no? 110.
No, you can't use 110. The max you can use is 105.
That means telling you, when they get a tolerance, you have to know what is the maximum, what is the minimum can be accepted. That is the way we calculate it. In this case, we get 105 ohm okay, maximum, 95 ohm okay for minimum. If you get a value 110 ohm, that's not good.
So, Mr. Pham, if we get a resistor and we want to put that resistor in the circuit, that resistor, when you measure it, it's got to be anywhere from 95 to 105. And even though you want a 100 ohm resistor, long as the resistance is 95 to 105, it'll work.
Exactly. The thing is, no way you can get exactly 100. That's why everything has to be get tolerant, plus or minus something. If you get 94 ohm, no. If you get 97 ohm, that's okay, right?
Right.
Or you get 102 ohm, that's good enough, right?
Right.
They have to be in the tolerance. Okay? Any question about the tolerance? That means you have to find out what is the maximum or minimum can be accepted.
So in this specific example with the mega ohms, we would say the tolerance is from 95 mega ohms to 105 mega ohms.
Okay, let's see. You see violet here, right? Will be the tolerance. What the tolerance we can get? Plus or minus here. Okay? 5%. That means any value. Okay? I given you. I take that out. Okay? I can calculate quickly here.
What value did he give?
100 mega ohm.
Oh, 100 mega ohm. So you need to take 5% of 100 mega ohm.
Yeah. Plus and minus what they give, 5%. So the first thing you have to calculate for the blood 5%. That means you take 100 mega
that's 5 million.
times 5 divide 100. Right? So what you get? Times 5 divide 100.
5.
5 mega.
Yeah, 5 million. 5 mega.
And if you get a minus 5%, they calculate the same thing, right? And they will be given to you minus 5 mega ohm. So that means they want right here 100 mega, and that will be 105, right?
Right.
And that will be
95.
perfect 95. So from here to here, accept it. No. No. That means if you get, okay, 101 mega ohm, is it okay or no?
It's gonna be
Yep.
Good, right? They less than 105 and they higher than 95. Okay? So that basically we're talking about tolerance. Okay? Now, this is just a very simple thing. You have to read conductance G is defined as a measure of materials ability to allow flow of charge and is size Simon unit. Okay, so basically they just talking about G will be Simon and just opposite to the resistance. And yet nothing else. They allow the current flow. G will be equal 1 over R. G unit will be a Simon. Okay. And now if they say, I want to know conductance of 5 ohm. So G will be equal 1 divided to 5. Okay. And unit will be a Simon.
Yeah, can you show us that equation real quick?
What equation?
For conductance, I just want to make sure I understand it.
Okay. G equal 1 over R. So if you get a 5 ohm, 1 over 5. 0.2, right? That means if they given you value of resistor, you can calculate the value for the conductance. And the unit conductance will be a Simon. Okay? Is it clear for you?
Yes, thank you.
And remember, conductance opposite to the
Resistor. Yeah.
resistance will be opposite to the current flowing, but the conductance will be allowed. the current flowing.
Right, so G equals 1 over R, and that also equals G equals I over V.
You're talking about the R, right?
Yeah,
Equal V over I.
yeah, but conductance is the inverse of resistance, right? So
Right.
wouldn't it be G equals I over V?
No, we don't care about that.
Okay,
Really do care when we go to the next one. You know R, then you know how to calculate G. Okay? Don't relate it into the other formula. That make confusing.
okay,
Here. Everyone learning in electronics, but no Ohm law. Okay? Now you get the circuitry. You get the power. E volt. You get the resistor. And the current will be flowing here. Okay? Then the current flowing here go to the R. That will be positive. Leaving R will be negative. Okay? This is the current flowing from positive of power. Okay? To the negative of the power. Now I try to explain to you how come you get the current. The reason is when you get the current, the thing is you get the electron in the material they flowing. Okay? Electron will be moving opposite. They're moving this way from negative to the positive. Okay? So basically, they moving opposite to this current. However, they're just talking about electron moving. They're talking about conventional current. Even the same, exactly the same. However, we're using conventional. Okay? That means the current all the time will be flowing from positive to the negative. However, the reason we get the current flow is the electron moving. Okay? And yet, now, in that current flowing, they going with the Ohm law. First thing, the total voltage E equal I times R. Take the current times resistor. From this current, if you want to calculate the I will be E divided to R. If you want R, you take the E divided to I. In here they say, where E apply voltage in volt, I is the current in ampere, R is the resistance in ohm. The length, okay, of this figure here, 25 milliamp, when connect to a 6-volt battery, okay, what is its resistance? So they asking for the value of resistance here. So the formula will be R equal E divided I. That gives you 240 ohm.
Quick question, Mr. Pham.
For everyone. If we're talking about Ohm law, if you want to calculate the E or V normally, either way, that be fine. Then you know how to calculate it. If you want to calculate the current I equal E divided R, or you want R, okay? that is your job. You must be know the formula. Also, they're talking about calculator power. Okay? When you see the light on, your arm, the light bulb, if you touch it, they will be hot. Okay? That means they converting into the power. Okay? In the electronic, they get the formula to converting into the power. Okay? First formula, P equal I square times R. That's the first formula. The second formula, P equal V square over R. And the last one, P equal V times I. Basically, we get three formula. In this formula, P will be in watt. How many watt? I will be in ampere. R will be in ohm. That's why when you go to buy the light bulb, it's asking 50 watt, 100 watt, 150 watt, okay? Depending on how many watt. This is a formula to calculate the power. And make sure, every time you're using calculator power, you know the formula. Okay, now we're talking about series circuit. What they said, current is the same everywhere in the series circuit. Total resistance equal to the sum of the individual resistance. The total voltage is equal to the sum of IR voltage drop across individual resistance. Total power is equal to the sum of the power dissipated by each resistance. That just summarize. Okay. Now, I get the circuitry. When you're looking into this circuitry, how many resistance?
Three.
How many?
Three
Three.
resistors.
Three, right? You can see one here. 1, 2, 3. Okay? The first one will be 2 ohm. Next one 6 ohm. And the last one 4 ohm. The power will be 24 volt. The very important here, when you're looking into the circuitry, in the DC, you get two types of the circuitry. One they call a series. The other one they call a parallel. How do we recognize which one? Okay, now I'm talking about series first. In the series circuitry, all the current flow through first one, second one, and the last one have to be the same current. That means you get only one current. Okay? That circuitry will be series. Another one they define. That means the resistor in series will be connected end to end. That means this one, after this one, they go to the next one. After next one, they go to the next one. They keep going the same. That will be in series. However, easy way. If the resistance get the same current, they will be connected in series. Okay, series. Current is the same through each resistor. Voltage across each resistor is different. Power dissipated by each resistor different. And total resistance of the circuitry, just add them up. Now, first thing, if they asking about total resistance for this circuitry, total. Then you can say R1 plus R2 plus R3, right? So that total resistance, you can add into S12. Correct?
12, yeah.
2 plus 6 plus 4.
Let's see, 2 plus 6, 8 plus 4, 12.
12.
So now you can get a new circuit. Okay, now you can get a circuitry. Let's see, 24 volt. And now you can get only one resistor that equals 12 ohm. Okay? They're telling you, you substitute this circuitry, okay, by another one, that one, 12 ohm. And you can get the current flowing here. And you apply the Ohm law. I equal E. So 24. Given you 2 ampere. That is how do I calculate the current. And you can do it the same thing. If you say, okay, ITI equal E divide R1 plus R2 plus R3. Same thing. Okay? Current will be, we calculate will be 2 amps. Now, you need to know, when the current coming in, this side will be positive. And the current leaving, the other side have to be negative. Same thing here. And same thing on that one. Okay? So when the current goes to R1, the voltage on this side here and the voltage on this side here will be different. What voltage on this side? How many volts?
24?
24, right? So when the current goes to the resistor, so basically at the resistor R1, okay, electrical converting into the thing is you get a power dissipation from R1. So the voltage on this one will be less than 24. If you want the voltage at R1, how do we calculate the VR1? You know the formula will be V equal I times R. I R1.
That'd be 4 for number 3.
Joule times Joule will be 4. Correct?
Correct.
4 volt. So basically, you get the 24 volt here, and now you dissipate it. Okay, you get 4 volt dissipated around R1. So basically, on this side, you can get 20, right? And now, if you want VR2, same thing, I times R2. I is 2M, R2 will be 6, 2 times 6 will be 12, right?
Right.
12 volt, okay? And VR3,
Same thing.
I times R3.
2 times 4.
So basically, 2 times 4, 8. Okay? So you can get the voltage drop around R1 will be 4 volt, R2 will be 12 volt, and R3 will be 8 volt. If you add them up, they both be equal 24. Okay? 4 adding 12, 16 adding 8, 24. Okay? If you get the difference, you get a problem. The thing is supply 24, and they go in through the circuitry. They have to be 24. And now, if you want to calculate the PR1, okay, then you can get the formula. I not calculate it, I give you formula. I square times R1. PR2 will be I square times R2, I square times R3. Okay? So, that will be, okay, calculate on of the power. PR1, PR2, PR3. Okay? If you want to calculate the power with this 24 volts, the formula will be P total equal E times I. Okay? That's right here. P total, V times I. Okay, now I will be talking about circuit again, okay? Gee, man. Okay, anyway. Okay, when you say this circuitry, you know that will be positive, negative. What is it here? What is it?
Can you repeat the question?
What I asking you guys, if you're looking at point D here, the symbol here, what is it? What symbol for? when you see this symbol, what is it?
Oh, you mean the ground?
Right. That's what they call common. All round.
Hey, Mr. Pham, if we could ask you to use your pointer so we know what you're talking about.
Okay. Sorry. That one, right?
Yeah, there you go.
Yeah, thank you.
That's what we call common. Around. If you want to measure voltage across R1, that means from here to here. We call a V R1. By definition, VR1. That means the voltage from A to B, correct?
Correct.
That means equal VA B. And that will be the same. That means VA minus VB. Okay? And VR2 BC from B to C, and that must be VB minus VC, VR3. VCD from C to D. That's a very, very basic. You must be memorized. If I say VAB, what that mean? VA minus VB. Okay? VBC means VB minus VC. Now, when you're working on the lab, they say they want to measure VB. When they want to measure VB right here, they say only single point B. If you get a meter, to the high side of the meter connect where? Low side connect where? Later on to see DMM. Positive. DMM. Negative. You can see you get a meter here. Okay, that's what they call a DMM. Digital multimeter. You get the positive here, you get the negative here. Okay? For measure the voltage. Okay? Right now we not teach you how to using that. Monday, that instructor will teaching you. Okay. However, what I said, they want to measure VB. Only one point. Then the other side of the meter must be connected to ground. So DMM positive connect to B. And DMM negative connect to ground. Remember, when you measure only single point, the other side of the meter must be connected to route. Okay? And if they say, I want to measure VBC, then the DMM high connect to B. DMM low connect to C. You see the difference, right? That means when they want to measure the voltage, VBC mean here. And high side of the meter connect to this one, low side connect to this one. However, if they set only single point, then the other side of the meter must be connected to the route. Okay? Okay, so this is just the next thing you want to know. Voltage divider groups. Okay, so basically you can get this voltage here. If you want the total resistance, 2K plus 8K. If you want to get a current, you take power divide total resistance. You get total current. Okay? And if you want the voltage across R2, they want the voltage across R2 here. We call it VR2. Okay, how can we get the VR2? Basically, you can say I time R2. Correct? VR will be equal to I times R. In order to apply this formula, you need to calculate the I. What I equal? I equal, the formula will be equal E divide R. In general, E divided by R. In here, you can get R1, R2 will be R1 plus R2. That means you get I. Then you're using VR2 equal I times R2. Then you can get VR2. Now, they're talking about voltage divider. If you want to using the voltage divider, I can do a calculation this way. VR2. Okay. Equal, let's see, E times R2 divide R1 plus R2. Instead, you have to calculate current I here. You don't need it. You're using this formula. Okay? You're able to calculate the VR2. That's what we call a voltage divider law.
So basically, this is a way to do it without amperes, right? That's what you're saying?
Without calculate current I.
Okay, cool.
Now, okay. I asked you a question before we stop it. Okay. If you want to calculate the on this one, VR4. Using the voltage divider, you want to calculate the voltage here. First thing you have to take E time what?
R4.
Perfect. R4 divide by
R.
what?
R.
What R?
R1, R1
R1,
plus R4.
R1 blood.
R2 plus R3 plus R4.
Perfect.
Yeah.
R1 blood R2 blood R3 blood R4. You understand the E divide total current volt resistance? That means you calculate the current, right? If you take the total power divide total resistance, you get the current I. And now if you times R4, that means you get the voltage for R4. So they just try to make it more simple. Instead, you need to calculate the total current. Then you can using voltage divider. That is the voltage divider law. Okay? So now we will stop it. You get any question, anything, or any suggestion. Just bring it up. Let me know. Okay? We try to help your guy understand whatever we get through it. Okay? And that will be build the basic understanding for anyone never know anything about electronics.
Hey, Mr. Pham, so anything that is missed, or if a student wants to know something, they can just look at this on YouTube, correct?
You mean which one? YouTube or
No,
what?
no. If a student wants to know something, because this has been recorded, it'll be on YouTube, correct?
Yeah, that means if you want it, then you can go to the web, go to the video,
Okay, yeah.
and you click on that, they will be display running whatever we're talking about.
Right, got it.
Anything? No question? Nothing?
Yes, for Monday's lab, what do you want us to go in prepared with? Like, do you want us to finish the assignment 1 or all assignments?
No. Assignment will be given you a time. You don't have to be hurried. Okay? You have to go, like, you get 3 or 4 assignments, keep doing it. Okay? We don't forcing to you to limit on the assignment. The thing is when you upload it, we can check it out. Only make sure you can get up to the point we want.
Okay.
Don't forcing anyone. Try to, you have to done on assignment 1 or 2 or 3 or 4. We don't care. But anyway, you have to working on that.
Okay, I have a question.
Yeah.
Oh, go ahead.
I'm wondering, what's the first formula you would recommend for us to actually make sure we memorize? The most important one.
Ohm's law.
I'm lost.
Yeah, I was thinking that too, actually, but besides that one, I see there's a couple already.
Yeah, when next time I get a little review before we start. Okay? That means a little quiz, few questions. And you can try to see you understand or not. And I'm telling you, okay? Only
Okay.
thing that when you're looking into circuitry for now, can you tell me the circuitry connect in series or parallel? Next time we're talking about parallel. That is the first thing. Second thing, I say I want to calculate the total current. You know, I want to be divided, right? R1 plus R2, R3, R4, R5. Or if I want to calculate the voltage at point B, then you have to understand from B will be to the ground. Or if I say I want the voltage AB, VAB, you have to tell me VAB means VA minus VB. That's a very basic thing we have to know. Just for a while, you get along. Not only one day, like you're able to know, get everything.
I'm gonna have to review the voltage divider rule because I don't know. I think I just lost it there for a few minutes, but I may have some more questions later. Oh, let me take a picture of that.
You mean you don't have to take a picture, you can go into the video on the website.
Okay.
You can see what
Thank you.
happened. Okay. However, before we stop it, I want to quickly I go to that one.
Yeah.
Now, if you get a circuit, one, two, three, four. That will be around same thing. R1, R2, R3, R4, point A, B, C, D. Now, if you're looking at that one here, okay, E total. You can calculate the current I, right? And I equal E divide R1, R2, R3, R4. Okay? Law, right? So if you want to calculate the now V R3 if I want VR3, so you, in general, you tell me VR3 equal. I am correct. I
Yeah.
am R. Okay. However, R3, that VR3. How can I calculate I? This is a formula calculate I here. However, now I want a voltage divider law. Then what VR3 equal?
It's the E times R3 divided by R1 plus R2 plus R3.
A times R3 divide R1
R1,
plus R2
R2,
plus
R3.
R3 plus okay. You want the VR3 to take the I times R3. Okay. E divide by R1, R2, R3, that will be I. Instead, you have to calculate I. You don't have to. Okay? Or if I say, I want VR4. You can using E divide, same thing. R1 plus R2 plus R3 plus R4. And this will be multiplied by R4. That's what we call a voltage divider law. Okay? So, anyway, we'll be stopped.
And Mr. Pham, if you look at the formulas you just put up, VR3 and the VR4, in the denominator of the VR4, you got R1, 2, 3, 4, and you're looking for R4. And up top, you're looking for R3, but you got 1, 2, 3, 4. Shouldn't you just have 1, 2, 3?
No. That you know why you divide by 1, 2, 3, 4. That means you get the current right here.
Because you're replacing the I, right?
Right.
Okay.
Instead, you want I before you can calculate I times R3, I times R4. Now you combine it into one formula. That's what they call a voltage divider law. Okay?
Oh, vote. Okay, all right.
Okay, will be more things you will be learned on Monday. Okay? They will be teach you how to get into the system computer, how to run the lab vote. Okay? What needs to be done. That will be from Monday. Tuesday, Wednesday. Okay, when you come, just do what you already know, how to do it. If you get any question, if I'm there, you can ask me. Otherwise, let instructor take care. Okay?
Any books you recommend?
No, not recommend anything. We'll see.
There's books in the website if you want to check those out.
Okay. If you want to take them up, I try to see. I can show this one here. Okay, you go into that one. You go into video here. See that? That's a video. Okay. And on the 2024, I will be uploaded either tonight or tomorrow. Okay. Or you want to see what the lab on the DC fundamental. Okay. You see that? From Mr. Tai, from last semester. You can click on that. Okay. And now they will be running. Okay. From last semester. This semester, we don't need that anymore. We get that video.
Also go over the VC fundamental boards in detail, okay?
Okay.
You can select specific types. We will concentrate on only basically 3 types that we went over and 1 additional types. Okay, so here is down at the bottom, LED will lit up. Well, right now, okay, because this works on the considers 1 node like we talked about it. Okay, there's only a piece of wire between here and there.
Okay, so that will be helping you. If you watch before you coming on Monday, that will be help a lot. More things to get it done. On the left phone, you can take it easy. Okay? Only thing we want, you have to get it done. I'm looking into the history of the server. I know. You done or you not done. Okay? So we'll see you later. Have a good night.
Bye, Professor. Thank you.
Bye.
See you next Thursday.
Thank you.
Thank you.
You're
Have a nice
welcome.
evening.
Yeah, bye-bye.
Goodbye.